Hi guys, and welcome to our unit on trigonometry. I'm excited about this unit because I personally enjoy trigonometry. I think it's a lot of fun, a little bit more hands-on than some of the other things that we do in algebra. So I'm excited about that. A couple things. One thing is in the margins, I will have mentioned where these ideas are in the Big Ideas textbook so that you can find them there, because we are not going to be following the Big Ideas textbook exactly, but we are kind of. So anytime that it is in Big Ideas, I will write it in the margins so that you can find out where it is. Another thing is I will just give you a word of warning. I might have tried to fit too much on one page. And so when you're writing things, you might want to write small because we have to kind of fit them in. So take that into consideration. Another thing, the last little bit of warning, is I might say if you have a couple different colors, some of you like to take notes in several different ink colors, for instance, I would recommend that because we are going to be looking at things in different ways, and each way might get a different color. So those are just some words of warning. Let's go ahead and jump into the information. You guys all know what angles are. You have learned about acute angles and obtuse angles and right angles and all these things. We're going to talk about what happens when we put those angles on a coordinate grid. So in your previous life in geometry, you just had an angle, a random angle. Now we are going to take that angle and we're going to put it on a coordinate grid. And we call that grid the unit circle, and we'll talk about that as along the way as well. But a couple things you ought to remember about the unit circle is it starts over here on the right-hand side at 0, and then up here will be 90 degrees, over here 180, down here is 270. As I go through this, I'm going to assume that you did the paper folding activity, but some of you might not have. So if you have not done that, you might want to go back and do that if this is not enough information for you on this video. And so when we first start putting angles on the unit circle or on a coordinate like this, we talk about what is standard position, because really we could put it anywhere, right? Well, we don't want to put it anywhere. We want to put it in standard position so that we all understand what's going on. Standard position is when the first side, the initial side, is on the x-axis, right here on the positive side of the x-axis. And then we draw our angle, and it's like we're opening up the angle, and it opens up and it comes over here, and here's the terminal side. Now, if you know anything about vocabulary or if you're taking another language, initial means the starting, right? So we start here. Terminal means the end. And so the angle starts here and it ends here. That's the initial side and the terminal side. The vertex is here at the origin. That's our vertex. We need to understand the standard position. We're going to be using it a lot and referring to it quite a bit. So two things you need to remember. It starts on the positive x-axis. Also, positive is counterclockwise. And so when you first start into this, it might seem kind of counterintuitive, but it's not. This is how we are always going to go, positive direction. Now, I will mention some angles end up going the negative direction. So you can have negative angles. That's just a little bit of forewarning. But positive direction really means we're going counterclockwise. Okay, in this next bit, we're going to talk about that negative angle as well as a couple other things. One thing is you can have an angle of more than 360 degrees. For instance, if this is my initial side, I could take this angle and I could rotate it as many times as I need to until I get to the stopping point. Let's say the stopping point is here. Okay, I just went around. I started here. I went 360, 720, and then some more. And so this angle, I don't know, this is going to be about 750 degrees, let's say. Okay, you can have an angle of more than 360 degrees. Why would you want that? Well, sometimes, like think about engineering. If you're engineering a screw or some other thing that needs to turn and you need to know how much do you turn it, you're going to have to describe it more than 360, right? If you have to spin it a couple of times to get where it needs to go. So we can have angles which are more than 360. That's one thing to remember. Another thing, if you already wrote this down the margin, you need to make a little adjustment because I don't have that on my font. There is this symbol and it looks like an O with a line through the middle. Sometimes when I do it in handwriting, it might look like this. Sometimes people who handwrite it make it a little bit more wavy in the middle, but this is a theta. Theta is like an x in trigonometry. And so commonly when we are referring to angles, we'll call them theta instead of calling them x. but that's what that symbol means. So when you see me draw that or you see that in print, that is a theta, and it's just like an X. Okay, let's practice a little bit with standard position. Another thing to mention, these monitoring progress, these are in your textbook, and I believe they are ones that you can try on your own with your textbook. I haven't actually done that before, so I'm not 100% on that, but let's just talk about drawing angles. And so if we are going to go 65 degrees, we have a vertex here. We start on the initial side. Now remember that up here would be 90 degrees. We don't need to go all the way to 90, right? In your mind, can you visualize how big 65 degrees is? I'm going to estimate maybe like that. And when I draw this, I draw the initial side, I draw the terminal side, and I also draw this little angle or this little arrow that's showing it's like this is the way it's opening up. It's going in a positive direction. I could also, if I wanted to, call that theta. Or I could call it theta equals 65 degrees. Anyway, that's how we draw a standard angle, an angle in standard position. Let's look at the next one, 300 degrees. Well, once again, we're going to start at the vertex. We're going to start with our initial side over here on the x-axis. We're going to go around 300 degrees. Okay, let's just remember our unit circle for a second. Okay, to get to 300 degrees, we're going to go all the way over to 270 and then go 30 degrees farther than 270. So this angle is this piece right here. And that's why that arrow, like this arc that I drew in here, that's why it's important to show that we're going this way. We're not going this way. Now, we could go this way. We'll talk about that in a little bit. But in this case, we are going this way. We went 300 degrees all the way around here. If we had gone this way, that would be going the negative direction, and that would be a negative angle, and you can do that. In fact, let's do a negative angle for this one. It says negative 120. Okay, we have to count backwards. So everyone knows, don't you, that can you see that down here will be negative 90 degrees? And so we're going to go negative 190. So that means this will be negative 180 over here. And so if we're going to negative 120, that's like 90 plus 30. And so I'm going to start on my initial side. I'm going to go in the negative direction, and I'm going to go negative 120 degrees. The last example here is going to be a negative 450. That's more than 360 degrees. We still start with the vertex at the origin and our initial side on the x-axis. We're going to go negative 450 degrees. Okay, so that means we're going in the negative direction, and we're going up to 360, but then we have to go farther. How much farther? Well, we have to maybe think about it in our head. But 450 degrees is 360 degrees plus how much? Well, plus another 90. So I went 360, and I'm going to go another 90. And this is going to be my 450 degrees. Looks kind of funny because it looks like a 90-degree angle, or maybe it looks like a 270-degree angle, but we're actually calling it, excuse me, I forgot my negative, a negative 450-degree angle. Started here, went in the negative direction, 360 plus another 90, and that gave us negative 450 degrees. Okay, again, back to that paper plate or the paper folding activity. Radians is another type of measure. We all know how to measure in degrees because we've done it before. But there is another angle measurement called radians, and it actually is easier a lot of times and makes more sense sometimes in trigonometry. And so we're going to start to get used to what does that look like. Okay, so going back to our unit circle and our quadrants and all that, so we know that this is our first quadrant, second quadrant, third quadrant, and fourth quadrant. We know this is a 90, 180, 270, and 360. If you have done the paper folding, then you know that there are 2 pi radians in 360 degrees. And if there are 2 pi in 360, there must be 1 pi in 180 degrees. And if we went halfway, that must be pi over 2 up here, and that must be 3 pi over 2, or 1.5 pi over here. Now, those are things that you're going to have to start memorizing. You have to know them and understand them, but mostly memorize them at this point. If you have not done the paper folding, I recommend you do that. Because sometimes we might need to convert from radians to degrees, because various reasons, mainly probably so that we all know what we're talking about. So let's talk about how to convert that, and that's going to be our last skill on this video. Now, it does not ask you to draw a diagram, but sometimes I think it's helpful to draw a diagram. So I'm just going to draw this to see where we're at. If I went 135 degrees, that would be 45 more than 90. So this would be my 135 degree angle. I have to think about, okay, where is that then in terms of radians? And so that's what we're going to do here. This is a lot like if you have taken chemistry and you've done unit conversions in chemistry, it's very similar. Because a minute ago, I said that 180 degrees is pi radians. And so that's going to be kind of our unit conversion. You could say that 360 degrees is 2 pi radians, and that's our unit conversion. That's fine, but that can be reduced, and that's why I use this one, is because it is reduced. And so that's what they're talking about here in this book page. I just cut and pasted this from the book. This is what they're talking about here on page 471 of the textbook. If you wanted some more examples, some more explanation, you should go there. But getting back to that unit conversion, what we're going to do is we're going to convert this over to radians. And so to do that, I'm going to put 135 degrees over 1. And back to this idea in chemistry of unit conversion, I want to convert that to radians. And so to convert that to radians, then I need my radians in the numerator and my degrees in the denominator. That way the degrees will cancel. So 180 degrees is pi radians. I'm going to go and do a couple of things. Like I said, the degrees cancel. So now I have 135 pi over 180. I'm going to go to my calculator and see what is 135 divided by 180. And I'm going to reduce that fraction. Well, my calculator says that it's 0.75. Now, I need my pi, so I don't want to leave off my pi, but I'm going to make that a fraction. When we talk about radians, we want them in fractions. We do not want them in decimals. I just did this on my calculator to kind of understand it, to help you understand it. We need to reduce 135 over 180. And how does 135 over 180 reduce? What does it reduce to? It reduces to 3 pi over 4. Now, the pi is because of this pi over here. It's still there also. So the degrees canceled. The pi is still there, the radians is still there. My answer is 3 pi over 4. Okay, remember I warned you, you might need to write small. And I wrote too big there, so I scooted mine over, which I know you cannot do, but you're going to need to try to make some space for yourself here. Okay, next example. Again, you don't have to draw a diagram. It doesn't say you have to draw a diagram, but let's understand where this is. A negative 40 degrees is down here. Okay, so just keep that in mind as we're doing this so that we know even what we're talking about. So I'm going to take my negative 40 degrees, put it over 1, multiply it by degrees on the bottom, radians on the top. So I'm going to have pi radians over 180 degrees. Again, my degrees cancel, my pi and my radians stay. I want to reduce this fraction. So basically, what is 40 over 180 reduced to? And that reduces to 2/9. Just let me mention something on fractions. 3 pi over 4, you could put the pi in the numerator, okay? Or you could put it outside. It does not matter. It means the same thing. So you could say 2 pi over 9, or you could say 2/9 pi. Either one is the same thing. These next two examples are doing the same thing. They're just going the other way. One thing I wish they had mentioned, put the labels on these. You need a label. So this is 5 pi over 4 radians. This is negative 6.28 radians. We're going to convert those to degrees. To convert those to degrees, we're just going to go the other way. Okay, when I do this, I'm going to set it up. I'm going to have 5 pi over 4. My radians goes in the numerator. To multiply it, to get rid of the radians, I'm going to put the radians in the denominator. So I'm going to have pi radians over 180 over here. Now, when we think about what cancels, this radian and this radian cancel. Also, this pi and this pi cancel. And so now I have 5 times 180 over 4. And you can reduce those fractions any way you want to. I happen to know that 5 times 180 is 900 over 4. And everything is canceled out except for my degrees. But of course, I do want to reduce that. So I have to take 900 divided by 4. And that looks like 225 degrees. And again, keep your units on there. They didn't put a unit up here. I wish they would have, but they did not. But we want a unit on our answer always. Last one. Negative 6.28 should mean something to you. Does that mean anything to you? Remember that pi is 3.14 approximately. So this is like a negative 2 pi. Actually, that's it. I'm done. The answer is negative 2 pi. Okay, but maybe you hadn't seen that. Actually, it's negative 2 pi radians, right? Well, we don't want radians. We want it in degrees. So let's go ahead and convert it over to degrees. So we have a negative 6.28 radians over 1. We're going to multiply that. This time we're going to put radians in the denominator and degrees in the numerator. So we have 180 degrees over pi. We're going to multiply. All right, what cancels out? The radians cancel with the radians. Now, if I think about this in pi's rather than in 6.28, isn't that negative 2 pi? That's what I said a second ago. You don't really have to do that, but I think it makes more sense. And this is what I'm saying, that sometimes radians make more sense. Okay, so let's just get rid of that because we changed it to negative 2 pi. Now the pi and the pi cancel. The answer is negative 360 degrees. And that should make sense to us that 2 pi goes with 360, so negative 2 pi goes with negative 360. All right, there was a lot of information jammed into this page. So like I said, if you need to go back and look at the big ideas. I gave you the section numbers, and then try some of the problems from the assignments.